Hi girls, let's take the last lesson in this chapter, which is lesson fact 88, factoring by grouping. So we have been discussing about grouping for three terms and on these two forms. So we learned how to factor x to the power 2 plus bx plus t. Then we had just more complicated thing by saying ax to the power 2 plus bx plus c. We also learned how to factor special case, which is on the form a to the power 2 plus 2ab plus c, which is equals to, that's what we learned, which is equals to a plus b, all this to the power 2. If here negative, so here is also negative. We also discussed about if we have a to the power 2 minus b to the power 2, that is will equals to a minus b times a plus b. So miss, what is the new in today's lesson? Today's lesson, nothing new, but we will have not only three terms, we will have four terms. Let me show you what do I mean. But before I move to that, let me tell you what is the meaning of factoring by grouping. So factoring is by grouping, which means you will try to write, you can group, you can take the factor or the greatest common factor of two terms together and two terms together, then you will try to group them together. Let me show you what do I mean exactly. Like here, for example, I can see there is common between these two. I can see also there is common between these two. So what is the common here? I can see the common here is the 3 and n to the power 2. If you have variable, try to see the lower power, then take it outside. If you take n outside, n to the power 2, and also 3 and 12, between them also 3. So I don't need to remind you what did I do with this one, how I factor it n times n times n 3 times. So just if you look at these two, just take the lower power. So that's what I did. I took this outside. So what is the remaining here? The remaining here only n, because if I multiply 3n squared times n, it will be 3n to the power 3. And then if I factor this to 12 into two factors, I will have 3 times 4. So the remaining is from this side 4. Since I already took out or pull out the n to the power 2, so the remaining is only n 3, the remaining only 4. Plus, let me take here, what is the common between them? The common between them only 2. So I will leave inside n and here minus 4, because this one I can factor it out into 2 times 4. Here is same thing, 2 times n. So I took n and n because they are same. So minus 4. Now, this exactly the same as this one. I can take them again as a common factor. So that is n minus 4. Just take it out. The remaining is 3n to the power 2 plus 2. That's what you have. That's what you're supposed to do. Just write the remaining, pull this out, and then write the remaining 3n to the power 2 plus 2. Let me do with you one more example. If you want to check your answer, you can just multiply them again and check your answer. So let me do this one. What I have here again between them common factor, which is what is the common factor between them. So I can say that is 2 times 7. I can say here 2 times, for the number that I have, 2 or the coefficient, 2 times 4. For the t's, here I have t to the power 2, t to the power 3. I will pull out the lower power, which is t to the power 2. And 2. So outside 2 t to the power 2, then open parentheses. What is the remaining from this side? 4t plus, what is the remaining from this side? Only 7. Plus, here, what is the common between them? I can say that is 5 times 4. I can say that is 5 times 7. So I can take out 5. So plus 5 outside, I will leave inside 4t plus 7. All right, great. That's what I need. This one, exactly the same as this one. So I can pull it out or just take it outside, let me say, or a common factor. So 4t plus 7 times, what is the remaining from here? Just take it, put it here. 2t to the power squared plus 5. Done. So that's the answer. Now, let me give you just one more or two more related exercises. So in today's lesson, we will finish it fast because it's easy and simple. So I'm not wasting your time doing exactly the same idea. I'm pretty sure you are so excellent in this part. So even it's easy, but it's new, but it's easy for you. So what is the common between these? I'm not doing again here. This is 2 times 5. This is 5 times 5. So the common between them is 5. Here I have g to the power 3, g to the power 2. So we have to say 5 outside, then g to the power 2, then open parentheses 2g minus 5. And then in the other side, I have to take outside. What is the common between them here? The common between them is 2. So just take plus 2. What is the remaining? 2g minus 5. Great. That's what I need. I will write my 2 here. So now this one and this one exactly same. So I will take it out. So 2g minus 5, open your parentheses, 5g squared plus 2. Let me do one more with you. So I'm going to do also with you this one. So here, what is the common factor between them? I know that this is a 3 times 6. I know that this is 4 times 5. So here I will factor this one more. I couldn't, maybe you cannot see it directly like that. So let me factor this 6 also into 2 times 3. So you can see the factor between them. Here is same thing 2. So the common factor between these two is only, not 4 here, sorry, 9. Sorry, that's 9. So what is the common between them? I can say also that is 9 times 2. So I can take outside only the 9 directly. 9 inside, the remaining is 2, 9h to the power 2. Again, take the lower power. And here you have 9 for the number. So 9h to the power 2. The remaining is 2h plus 5. Same thing with this. What is the common factor between them? So the common factor between them is 4, because that is 2 times 4 and this one is 4 times 5. So you can just say here, if you take 4, take the negative also as a common factor. So let me organize this one also. I will erase this part. I will rewrite it to show you more organized. So that is 9 h to the power 2. Inside the parentheses for this one, there is 2h plus 5. For this one, I will take minus 4 as a common factor. Then the remaining from this 8, 2h, because I took already the negative outside, so plus 5. Great, that's what I need. This one exactly the same as this one. So you can say directly 2h plus 5, 9h to the power squared minus 4. That's enough for this part. Let me move. So for this problem, I think I covered it by mistake, so I'm going to copy it from the book. So you have here factoring a polynomial completely. Sometime you have, if you have like this example, 4q to the power 4, look, the power is increasing for the polynomial. So this polynomial is 8q to the power 3, and you have a plus 12q squared minus 24q. If you scan or just have a look for all the terms that you have, you will notice that there is common between all of them, which is this 4. And 1q, one from these, 1q. So the greatest common factor between all these terms, there is a greatest common factor between all these terms, which is 4. And for the variables, you have to take this, the lowest power. The lowest power is 1. So I will take 4q. And then the remaining inside, if I take 4 outside and 1q, it will be q to the power 3. Here, minus. You took 4, so the remaining 2, so you can say 4 times 2, it is 8. And you took 1q outside, so the remaining q to the power 2. You took 4 outside, the remaining from this one is a 3. And you took q outside, so the remaining q to the power 1. Minus. What is the number that you should multiply it by 24 to get by 4 to get 24? It is 6. So just minus 6, and you already took q, so there is no remaining q. Now from this part you will go back to the previous step, so the previous problem. So q, and then again look at these two terms together and these two terms together and do exactly same thing. Let's do it. So here we have the common between them only q. So q, and then the remaining inside the q to the power 2 minus 2. All right. Then here you can see the common between 3 and 6 is what? 3. What is the remaining? Q minus 2. Great. That's what I need. Because if I don't have these exactly the same as each other, I cannot pull it out, or I cannot group them. This is the main idea from a grouping. Now I can group them. I will leave 4q outside. Then I will take q squared minus 2. I'll take it again as a common factor. What is the remaining? Q plus 3. You're done. So that's the idea. So the first step that once you look at any polynomial from any degree, or if you have any term, any number of terms, first of all, scan your polynomial. If you see all of them including variables, just pull out or take out the lowest power. This is the first step. Then look at the numbers that you have. If you have common between all of them, take this common, and then pull it out. Then write the remaining as I did. Then try to group and group again until you get the simplest factorization. Now let me do with you this one. So first of all, I can see here the power, the smallest power for my variable is h. Now when I scan my number, I will see, can I say 6? No, because this 9 I can factor it with 6. So can I say 3? Yes. So I will take 3 outside h. So what is the remaining from this one? The remaining is 2h to the power 3 plus 3h plus, what is the number? When you multiply it by 3, you will get 12, 4. H, only one h to the power 1 because you already took 1 out. So plus, what is the number once you multiply it by 3? You will get 18, 6. Just h, you already took it outside. Just take this part, take the common factor between them. So here, what is the common factor between them? H. So 3h, leave it outside. Now here you have h, and then inside 2h to the power 2 plus 3. Here there is common between them 2. So take 2 outside. What is the remaining inside? You have 2h plus 3. Great. That's what you need. So let me just check 1 second. If I take this h outside, so that is h to the power, that is to the power 2. So I must take here so that is h to the power 2 because I took 1 here, so that is h to the power 3. This one, if I took 1, it will be h to the power 2. So again, for these two terms, I have common between them. H to the power 2 is the lowest, the variable with the lowest power for these two terms. So I will take it out. So that's why, so the remaining is from this one, h to the power 1. Now let me continue working on that. So this one and this one exactly same. So just take it outside. So 3h times 2h plus 3 times h to the power 2 plus 2. That's the answer. That's the answer. It is really easy. It is simple. Let's do 2 more exercises. Let me do this one with you first. So first of all, I will scan all my terms. Do I have a coefficient and a variable in all of them? No, there is no variable. No variable here. So there is no common variable between all of them. I will look at the numbers now. I'll try to factor them. So if I will think about maybe here, step by step, I will think about 12 maybe 12. I can see 12 in all of them. So step by step, just think about it. If you think about 12, you will find one of them you cannot factor it by 12. So if you check 36 divided by 12, which is will give you 3, okay. 126 divided by 12, you will notice you cannot divide it. So in this case, you will take a smaller than 12. So you can say definitely 10 impossible. 7 and 9 you cannot, because 9, all these numbers are even numbers. So for sure you will look for even and even number to pull it out. if you think about it and just to try many numbers, you will find the greatest common. You can factor them all and see the factorization between them for all the numbers. I mean, you will make 168. I'm not wasting the time doing the factorization for all the numbers. So 8, and do the factorization for all the numbers, 126 and 36. Once you factor them, all of them, you will notice the common between all of them, 2 and the 3. So 2 times the 3, once you do this way, 2 and the 3, which means 2 times the 3, which is 6. So the common between them all 6. Just take 6 outside. So 36. If you take 6 outside, it will be, the remaining is 6v to the power of 3. All right? Now, let's move. Minus 126 divided by 6 and see what is the remaining. 21. So minus 21 v to the power 2 plus 48 is easy, you know what? It's 8 immediately. Minus 168, you can just do it by calculator. 168 divided by 6, which is equals to 28. So that is V. I forgot to write V. Here you have a 28. You will notice that here you can factor it, sorry. You can factor it. So we have 6 times. What is the common between them here? We can see common between them 3, right? So for the numbers, we can see 3, v to the power 2. V to the power 2. Open your parentheses. So here the remaining is 2. V minus 21. If you took 3, the remaining is 7, isn't it? Plus, what is the common between them here? Plus, the common between them is 4. So that is 4. Inside 2, v minus 7. That's it. So just pull out these, the one that exactly the same. So 6 times 2v minus 7. What is the remaining from this one and this one? Just write them here. 3v to the power 2 plus 4. That's the answer. So I hope this exercise is enough for you. So let me do with you this one. It is true here we have a word problem, but it's really simple and it's easy. So finding the dimensions of a rectangular prism. You know the volume for rectangular prism is just height by base and times the height for the prism itself. So the area of base times the height. So I mean, once I factor this one, I will find two things. I'm multiplying them by each other. So the basic idea here, I just need to factor this volume. So 6x to the power 3 plus 19x to the power 2 plus 15x. So they are asking you here what expression can represent the dimension of the toy when it folds up. Use factoring. So I need to find the dimension for these, the height, and these, the base and the height for the area of the base. So let's factor it. First of all, step 1, scan all of them. Do you have common factor between all of them? As a variable, yes, I have x. So I will take x to the power 1 with the smallest power. I will look at my number. Do I have common factor between 6 and 19 and 15? The problem in 19, no, I cannot. I don't have. So I will write the remaining things by just 6x to the power 2 because I took 1 plus 19 x to the power 2 plus 15. So that's the idea. Now if you took 2, sorry, that's a 1. Sorry, this is power 1. Let me erase this part. Now you will go back to the previous lesson. That's on the form a x to the power 2 plus b x plus c. So go ahead and do it in your corner. So what is AC? AC will be 6 times 15. So 6 times 15 will gives you 90. Now you can easily think about two numbers. Once you multiply them, you will get 90, positive 90. Once you add them, you will get 19. You can directly think about 10 and 9, 10 and 9, 10 and 9. Once you multiply them, you will get 90. Once you add them, you will get the number that's in the middle. Wonderful. So that is x plus 9 times x plus 10. I'm done. So these are the factorization for my prism. These are the dimensions for my prism. You can say these are the dimensions for your prism. You can write each one from them alone if you want. You can just say, okay, the dimension is, it's true, I'm not mentioning that because I did similar question before, and one from the students, she was telling me, Miss, you did not tell us that the dimension is just was one from them. So I'm telling you now, the dimension is, we can write them with comma. This is the first dimension. Sorry, the comma is down. X plus 9, comma. The next dimension is, which is represent length, width, height. So length, width, height. LW, length, width, and height. L times W times H. So these are the dimensions, length and the width and the height. It doesn't matter which one of them, the length and the height and the width. Let me give you a more related exercise. Again, I have rectangular prism with volume, this one. What is the expression can represent the dimensions of this prism? Use factoring. So again, 60, I will look at them all. Do I have in all the terms variable? Yes. What is the smallest power? X to the power 1. Take it outside. The remaining. For all my numbers, do I have common between all of them? Yes. The common between all of them is what? 2. All right. I will take it outside. Okay. So here I will have 30. I took x, 1x. The remaining is x to the power 3. Plus, that will be 17. I took x outside, so that's the remaining is x plus 2. Great. Now I will go back. That is 2. That is 2. Again, I'll go back to the previous lessons. What is AC? AC is, well, gives you 30 times 2, which is 60. Okay, think about two numbers. Once you add them, you will get, once you add them, you will get 17. Once you multiply them, you will get 60. So let's try maybe we can take other than 2 here. 15, 17, yes, that's correct. 4, so that is 2x, yes, that's correct. So 30 times 2, which is 60. So think about, we can say 30 times 2. We cannot, once we subtract them, okay, 20 times 3. So 20 times 3 will give me, I need one from them to be negative. So I cannot subtract, because once I subtract them, I will get 17. But I need something with addition. So I need to try many numbers to get the this answer. 30 is 60. That is 17. And then if I have subtraction, it will be great, but I don't have subtraction. Okay, we can think about also 15 and 4 and 2. So 15 and 2, once we multiply them, we will get 30. So that's still wrong. Once we multiply them, we will get 30. No. So that is also wrong. I'm going to think about it in many ways. I think there is a mistake here. Okay, let me go and give more exercise, then go back to this exercise to avoid wasting the time, because the time is running. All right, let me solve with you this one, which is exactly the same idea. I'm going to factor this box. So once I factor it, I will just look at my all terms that I have. I have C in all of them, so immediately I will take C. Now, is 4 common between all of them? I'll double check. I'll take my calculator and then say, see if 52 divided by 4, can I divide it? Yes. 160 divided by 4, yes. So 4 is also, I can see 4 is common between all of them. So 4C is common between all of them. The remaining, C to the power 2 plus, so 52 divided by 4, it is 13. So that will be 13. C plus 160 divided by 4 will gives you 40. Now you can also do exactly the same idea that we did before. We are going to think about two numbers. Once we multiply them, we will get 40. Once we add them, we will get 13. We can think about 8 and 5. Once we multiply them, we will get 40. Same two numbers, once we add them, we will get 13. So that's good. We could found this one easily. So plus 8C plus, here it doesn't matter the order for these, because you can plus 40, because you can 4C. Now 4C, drop your 4C. Now you can take common factor between each two terms. It's like you are grouping. So here you have C common factor between them. The remaining is C plus 8. You can take here the common factor between them 5. So the remaining is three 3C plus 3C plus, if I took 5, the remaining will be 8. So but the problem is here 3 and here is C. We cannot pull it out. I will check if I have mistake. Other than that, it will be the answer is just like that. The answer is supposed to be correct. This is supposed to be correct. Oh, that's a 5, not 15. Sorry, that's a 5. So since that's 5, so the remaining here will be 3. So that's correct now. So that is equals to, I'm going to write my answer here. For C, I will pull out C plus 8. So C plus 8 times C plus 5. Let me go back to the previous part so we can maybe find the or figure out the problem. Again, I would like to read you here. We talk common factor between all of them too. So once we factor them, we have 2x inside 30, 30x to the power 2 plus 17x plus 2. So 30 times 2, it is 60. I'm going to think about a number when I multiply it by, so we can say, we cannot say 30, 30 times 2. We cannot say also 20 and 3 because we cannot put them subtraction. Why? Because this is positive. So I will think about another two numbers. Maybe we can say 15 times 4 will give me the result, but the problem 15 times 15 plus 4 will give me 19, not 17. So I'm going to think about 12 and 5. 12 times 5. When I multiply them, I will get 60. When I add them, I will get 17. Great, that's what I need. So 12 and 5. All right, so let me write my answer here. So that is 2x, then 30 x to the power 2. I'm going to rewrite this part in the middle. So I'm going to say that is plus 5x because I can factor this 5 with this 30 while I will keep 12x plus 2. There is common between this 2 and this 12. So that is, just take 5 outside and x, one from the x's. Let me erase this part so I can continue in this space. So that is the remaining from here. It's 6x to the power 1 plus 1 because you took 5x, the remaining is 1. Don't write anything, just remove it. No, the remaining is 1. plus, just take 2 outside, the remaining is 6 plus 1, 6x plus 1. Good, that's what I need. I have to put this big bracket to make sure that this is including both of them. So 5x, I will pull out now 6x plus 1. Then the remaining is 5x plus 2. I'm done like that. I'm done from my lesson. Finally, I would like to summarize the idea. In general, all the lesson that we have been learned, what should we do? This is just a summary for all lessons that we learned for factoring polynomials. First of all, as I said, try to find the greatest common factor for all the terms that you have. If the polynomial has 2 terms or 3 terms, look for a difference or 2 squares, a perfect square trinomial, or a pair of binomial factors. So if you have 3 terms, I mean a polynomial with the greatest power 2, you can use the rules, that is the special case that we learned. If you have the greatest power more than 2, or I mean the terms, I mean the number of the terms more than 3 and the powers more than 2, just think about the way grouping. Try to find great common factor between all the terms that you have. If you don't have between all of them, try to group them each 2 together. If the polynomial has 4 or more terms, group terms and factor to find the common binomials factors. As a final check, just make sure that the common factors other than 1. So no common factors other than 1. So this is just simple and easy. Just make sure that you practice them. Good luck, girls. Bye.